Good morning, everyone. I am Sachin Fiske from Electrical Engineering Department, Assistant Professor, SMD College of Engineering and Research Center. Today, we are going to start new point, that is basics of control system. Here is the introduction. Control system are the integral part of our life and plays a very important role from a simple bread toaster to a complex power plant. Control systems are all around us and are inseparable part of the modern society. Some of the more commonly used control systems in our day-to-day life are washing machine, elevators, air conditioning unit, heaters, etc. Means in day-to-day life we are continuously using control systems, and so many control systems are we are going to use in our daily life. Also, we have a very advanced control system such as launching of a satellite in orbit, regulation of a generator in power plant, and all these control systems are designed by a human. But we must realize that we are not only the creators of the control system. Let us consider one example of our human body. Yes, human body is one of the best example of the complex control system, and in fact our body is made up of numbers of the elements, that is some respiratory system, digestive system, reproductive system, etc. Basically this chapter deals with the elementary definition, classification and various types of the example. Let us see one by one what is control system. Before going to this control system, control systems are the integral part of our life and plays a very important role from a simple bread toaster as we discussed earlier. Okay, see this diagram. Now in this diagram, basically this control system is an arrangement or the combination of various physical components such as, or these first components are called as subsystem, connected in such a manner so as to attain a certain objective. This a system has an input and an output associated with it. Let us consider a simple example of such a system is a lamp. So everyone knows that the bulb will be act as a system, and when this bulb is given an input of 230 volt, it start to glow, and this output means glowing of the bulb. Let us consider this diagram as shown. That is, in this diagram, we are giving 230 volt AC supply to this bulb, and from the output side of this bulb, we are getting a light, means the light will be considered as output. These are some definitions related to input and of the control system, then output of the control system, and what is exactly the control system. So the excitation or stimulus applied to the system from an external source in order to produce an output is called as input signal. Similarly, the output signal obtained from a system when input is applied is called as output of the control system. And to regulate or direct or command a system so that the desired objective is attained is called as control system. Okay, now we are moving towards open loop system. An open loop system is one in which does not automatically correct the changes in the output by adjusting the input signal. In open loop system, basically one control system and plant, that is operator is placed, and in this system means control action can be completely independent of the output, means a system in which the control action is completely independent of the output of the system, and hence it is called as open loop system. Here there is a no feedback element present, and generally this block diagram shows the output of the system. In open loop system means the output remains constant for a given input. There is no any disturbance in the output of the system, and it is provided given conditions are the same. There is no correction action taking place in this system, and very common example of an open loop system is a fan. When we switch on the fan, it starts rotating or moving with the speed depending upon the position of the regulator. It continues to rotate at the same speed till no human being changes the position of the regulator. See, in this diagram, the fan will be the object and regulator is nothing but the control system. When we are giving some input signal to this fan, this regulator, and this regulator will be connected directly to this fan and it gives some output signal. The output signal is a physical quantity in the form of air, and in this way this open loop system will be active, means the output is completely independent of this regulator. Here no feedback element is present, and hence we can say that the same system is called as open loop system. Now let us take an example of the electric hand dryer, automatic washing machine, bread toaster, then automatic coffee or tea serving machine. There are some advantages and disadvantages of the open loop system. The first advantage is they are simple in construction and design. Again, they are economic. Then it is easy to maintain. Means there is no any maintenance cost, or if required, it has a very small intensive cost. Some disadvantages are also there. That is, this system is inaccurate and unreliable because accuracy is completely dependent on the accuracy of the calibrations. And to maintain the quality of the accuracy, recalibration of the system is necessary time to time. See this diagram. This represents the closed loop control system. Here, start and stop buttons are provided. One pump is also provided. And basically, this closed loop control system has some information about the change in the process with respect to change in the input. Means, whenever we require somewhat changes in the output, at the same time, we have to change the input with respect to the error detector and the value of the required output. And now consider the previous example as shown in the error detector. So there are two types of switches given. One is for tank and one is for water level indications. So one is high level switch and second one is provided at the low level switch. Whenever this level will start to fall down, automatically this low level switch will actuate and start the input signal given to the water tank. When this tank will fill fully, then at the same time high level switch gets actuated and automatically the input signal given to this water tank will be off, and in this way this closed loop control system will be operated. Now in case of the control system, the same example can be calibrated in terms of the block diagram. So in case of the block diagram system, here is the input and one is output, and in between them one controller and processor will be placed. Okay, one feedback element is given from output to the subbing point at input. During this process, in case of this open loop control system, when we start the pump, we have no status of the tank level, but in closed loop control system, we have the status of this tank level as discussed earlier. But in case of this second system, if the tank level goes high and then high level switch actuates and controller stop the pump. So some advantages of these closed loop systems are these systems are basically accurate. They are accurate even in the presence of non-linearity. They are more stable and they are less affected by the noise. They are complex and expensive. The feedback in closed loop system may lead to oscillatory responses. These are some disadvantages, and more care is needed to design a closed loop system. The overall gain of the system is reduced due to feedback. Now some examples of the control systems are liquid level control system, then room temperature control system, again traffic control system and home heating system. Now here the open loop and closed loop system will be over, but in the next lecture we will start about the analysis of open loop and closed loop system by using the block diagram. Thank you.